Slide 1. Dear Chairman, dear colleagues, and guests. I am Automatic Text Reader and will present to your attention the work, entitled Definition of Assessment Criteria for Nesting Software Tools in Textile Production. With co-authors Liliana Indri, Julieta Ilieva, Irina Ruseva, Ora Simona, and Zlatan Zlatev. Slide 2. The arrangement of textile sewing patterns for cutting aims to minimize the amount of residual material, which in most cases is unusable and discarded. Comparative analyses of the presented algorithms have been performed. Different authors point to different accuracy within their study, which is indicative that the accuracy of the application of an algorithm depends largely on the type of problem to be solved by arranging elements for cutting textiles. Slide 3. The available software tools for nesting textile elements are summarized. Their advantages and limitations are presented. The advantages of using software products for arranging details are: reduce the operating time of the machine. It is realized by reducing the path of the cutting tool, double cutting in order to avoid the appearance of hanging threads. Effective use of textile material. Reducing the residual material leads to a reduction in waste. In the case of high-cost materials, this also leads to a reduction in production costs. Reduction of manual labor. By automating processes such as importing CAD files, you can drastically reduce CAM preparation time. The time to convert from CAD file to NC code can be significantly reduced. Slide 4. The most commonly used nesting algorithms are grouped into 6 groups. These programming procedures have been studied since the time when the problem of arranging cutting elements was defined. Some algorithms offer high-speed data processing, but low efficiency in obtaining large amounts of waste material. Due to the limitations of the independent use of algorithms, they are suitable for solving specific tasks. Hybrid algorithms, which combine the work of several algorithms, have a more universal application. Of course, at the expense of longer execution time, compared to the independent use of algorithms for arranging elements. In summary, the problem of cutting textile elements can be defined as, to arrange irregularly shaped elements in a rectangular field of known dimensions without overlapping. They should take up little space in the field. Slide 5. The purpose of this paper is to define criteria for the evaluation of software products for the arrangement of elements that are suitable for textile production. Slide 6. The software products Gemini CAD, Nest and Cut, Deep Nest, SVG Nest were used. Gemini CAD is a commercial software product for clothing design. It offers functions for arranging patterns that are optimized for cutting textile fabrics. Nest and Cut is a commercial online tool. It has a 30-day trial. The tool arranges the elements using several optimization algorithms. It has functions for simulation of textile cutting. Also, the obtained result can be downloaded as a DXF file. Deep Nest is free application. It has many setup functions, such as number of processor cores, allowable error value, sorting method. It uses the genetic algorithm to arrange the elements. The result can be downloaded as a DXF or SVG file. SVG Nest is also free online tool. Works only with SVG files. It offers several setup functions. Slide 7. An example of nesting software is presented as a video. The software tool SVG Nest is used. First, the CAD file with textile elements is loaded. Second, we have to select the place where the elements have to be nested. After some iterations, the 10 elements are nested, but only 63% of the material is utilized. Slide 8. The test of the software products is made by patterns for dress, pants, and blouse. Criteria presented in the available literature were used to evaluate the performance of software products. These criteria are relationships that do not depend directly on the unit of measure in which the variables involved are measured. For this reason, image processing techniques can be easily applied and the number of pixels can be used. These pixels can be converted to distance and area, for example in mm. Slide 9. In the present work, an algorithm for evaluating the performance of software products for arranging elements is proposed. Image processing and analysis techniques were used. The algorithm is implemented in the MATLAB software system. In general, it is presented on the figure. Stage 1 includes loading the RGB image of the solution for arranging elements of the corresponding algorithm. Stage 2 convert the image to black and white and filter. The filter adjustment factors have been experimentally established. A disk filter is used. Stage 3 determining the areas occupied by the elements in the image. The region props function is used. Stage 4 defining the criteria for evaluating the arrangement of the elements of the image. Slide 10. A summary analysis of the obtained results was made with the method correspondence analysis. The method is a technique for visualizing, detecting, and presenting the relationship between categories of data. It uses a graph called the correspondence map, which depicts the relationships between the data. The method is implemented in a software product Statistica. Slide 11. Results from a comparative analysis of the arrangement of elements of a dress. The highest value of the height of filling with elements, relative to the height of the fabric, is obtained with Gemini CAD, followed by SVG Nest. Again, the Gemini CAD shows the appropriate value of the weighted ratio between the empty space and the one filled with elements. Next on this indicator is Nest and Cut. As can be seen from the table, the material utilization rate and the overall efficiency of the algorithms are highest with SVG Nest and lowest with Nest and Cut. The set data processing time is 120 seconds for the three algorithms and 10 seconds for Nest and Cut. Slide 12. A comparative analysis of the arrangement of elements of coat. The highest value of the height of filling with elements, relative to the height of the fabric, is obtained at SVG Nest. Both SVG Nest and Cut show appropriate values of the weighted ratio between the empty space and the one filled with elements. Last in this indicator is Deep Nest. As can be seen from the table, the material utilization rate and the overall efficiency of the algorithms are highest with SVG Nest and lowest with Deep Nest. The set data processing time is 120 seconds for the three algorithms and 10 seconds for Nest and Cut. Slide 13. Results of a comparative analysis of the arrangement of blouse elements. The highest value of the height of filling with elements, relative to the height of the fabric, is obtained at Deep Nest. Both SVG Nest and Cut show appropriate values of the weighted ratio between the empty space and the one filled with elements. Last in this indicator is Deep Nest. The results show that the material utilization rate and the overall efficiency of the algorithms are the highest in Nest and Cut and the lowest in Deep Nest. The set data processing time is 120 seconds for the three algorithms and 10 seconds for Nest and Cut. Slide 14. A correspondence map for software products and evaluation criteria is presented. The two dimensions on which the data are presented accurately describe 99.9% of their inertia. This shows that two dimensions are sufficient to evaluate the operation of the algorithms for arranging elements. The evaluation criteria clearly stand out for the individual software products. The material utilization rate, DF, is closest to Gemini CAD. The fill height with elements, H, has the highest values for Deep Nest. The weighted ratio between the empty space and that filled with elements, F, as well as the overall efficiency of the algorithms, is closest to SVG Nest and Cut. The results of the correspondence analysis show that the choice of the appropriate algorithm will depend on the type of elements to be arranged and on what evaluation criterion is appropriate for the respective production of garment patterns. Slide 15. The results obtained in the present work complement those of the available literature. Comparative analyses of software tools are presented, which can be summarized in two groups, depending on their use and availability: online-based and local, commercial and free. The Deep Nest software, which uses a basic genetic algorithm, uses a method to approximate to rectangles. For this reason, it performs less efficiently when arranging elements with a complex shape than other algorithms. This result complements the claim of Syed and team that algorithms with approximation of elements to rectangles have a high complexity of the computing apparatus and are effective when working only with rectangular details. Although SVGNest has only a few possible settings, this online tool can be successfully used to arrange complex shapes, using the material much more efficiently than the other free DeepNest tool. The two commercial software Gemini CAD and Nest and Cut are comparable in terms of results, but Gemini CAD is optimized for the arrangement of textile elements for cutting, which is its main advantage in the task solved in this paper. The proven effectiveness of CAD systems for clothing design and offering functions for arranging cut elements complement the claims of Kozlacheva, according to which the design of clothing is the most important process in clothing design. Mistakes made during the development of basic structures can hardly be avoided in the next stages of design and technological production. The importance of design makes it the last automated stage in the whole sequence of activities that make up the design of clothing. The results obtained in this way complement the conclusions of Susikla and team, who point out that combining several algorithms is much more efficient than using stacking algorithms alone, but on the other hand it takes longer to calculate. Slide 16. In the present paper, a total of 5 criteria are proposed for the evaluation of software products for the arrangement of elements that are suitable for textile production. These criteria are related to the degree of use of the material, the overall efficiency of the algorithms and the time for their execution. Developed, researched, and used in the work software tool for complex, express, automated evaluation of algorithms for arranging elements, including software modules for research, analysis, and categorization of nesting software products. The software includes tools for processing and analyzing digital images and calculating criteria for evaluating nesting software. A comparative analysis is made of software products for nesting of cutting elements, depending on their use and availability. It has been shown that the choice of an appropriate nesting algorithm depends on the complexity of the items to be arranged and on what evaluation criterion is appropriate for the respective production of garment patterns. The main reasons for inefficient operation of nesting algorithms for cutting of textile fabrics are analyzed. It was found that the effectiveness of software products mainly depends on the complexity of the ordered elements and the optimization algorithm used. The results reported in the available literature have been supplemented. Procedures suitable for evaluating software products and algorithms for arranging textile elements are proposed. The following developments may be related to reducing the limitations of the proposed algorithm and the inclusion of more reasonable criteria to participate in the evaluation of software products for arranging elements. The results obtained in the present work can be used in the development of systems for evaluating the performance of algorithms and software tools. They can be used in the training of future specialists in the subject area. Slide 17. Thank you for your attention.